Okay, good afternoon, everyone, and welcome to the ONC Provider User Experience Challenge Phase 1 Winners webinar. My name is Adam Wong. I'm a Senior Innovation Strategist, Senior Innovation Analyst at the Office of the National Coordinator for Health IT. On today's agenda, I'm going to quickly give an overview of Phase 1 of the Provider User Experience Challenge. Then we are going to hear from our four Phase 1 winners from Herald Health. We have Craig Monson, Matt Fujisawa, and Brad Dyfus. From Phrase Health, we have Mark Tobias and Naveen Muthu. From the collaboration between University of Utah Healthcare, Duke Health System, and Intermountain Healthcare, we have Kensaku Kawamoto. And last but not least, we have Craig Lamoli from Wellsheet. And then we'll wrap up with a brief overview of Phase 2. So earlier this year at the HIMSS conference, the National Coordinator for Health IT, Karen DeSalvo, announced the Connecting and Accelerating a FHIR App Ecosystem initiative. So as we all know, the currently available technology that can pull information from different sources and present it in a user-friendly way is somewhat limited. But we are seeing numerous technology efforts that are getting us closer to solving that problem. And among them is FHIR, or Fast Healthcare Interoperability Resources. And in the spirit of the open development of FHIR, we feel that it is essential to involve the community and users in solving these problems. And so that's why we came up with a three-part strategy that involves two challenges and the Discovery Infrastructure for Clinical Health IT Apps Cooperative Agreement, which was awarded earlier this year to Boston Children's Hospital. So the two challenges are the Consumer Health Data Aggregator Challenge, whose intent was to help consumers aggregate their data all in one place under their control. And we had the winners present, the Phase 1 winners present on Tuesday afternoon. And of course, today we're talking about the Provider User Experience Challenge, whose intent is to enable innovative ways for providers to interact with patient health data and make using that data and accessing that data easier and better to use within the clinic. Participants in Phase 1 were required to submit mock-ups or wireframes of their proposed app, technical specifications, a business or sustainability plan that demonstrates how they intend to bring their solutions to market after the challenge, and evidence of provider partnerships that will allow for the testing of their apps. Basically, this is a material that provides a backup and supporting materials for developing an app with these requirements. They are required to use FHIR Draft Standard for Technical Use, or DSTU2. And you might ask why FHIR rather than making it more open. We chose to focus on FHIR because it's the one that we feel is the most developed so far and has garnered the most industry attention and energy. Apps are required to leverage data as specified in the 2015 edition Common Clinical Data Set. To demonstrate compatibility with different health IT developer systems implemented in production systems, preferably at least one of which is from the top 10 systems as measured by meaningful use attestation. Again, it has been tested with users in production settings, and it is available on the iOS store, the Android store, or one of the Android stores, or direct from the web. So with that, I would like to turn things over to Herald Health, Craig Monson, Matt Fujisawa, and Brad Dyfus.
Great. Just while I'm setting this up, can you hear me okay? This is Craig.
Yes, we can.
All right.
And we can see your screen.
You see my screen? Great. Okay. So I'm going to start out by motivating Herald, give a bit of a demo, and then kick it off to Matt and Brad for providing a little more color around the progress we've made so far. So at Herald, we're on a mission to solve the data overload problem for doctors. today, doctors are drowning in data, and it's only going to get worse with increasing digitization of clinical data, access to patient-generated data, the maturity of genetic data. All of these things clinicians need to incorporate in order to have kind of the situational awareness in order to know what's going on with their patients and treat them effectively. The problem, or exacerbating this data overload, is the fact that existing medical records currently are built on a pull-based model whereby, as a clinician, I need to continuously survey for any updates to patient information, whether that's labs, radiology, et cetera. So I know this pain because I just finished my residency in internal medicine. So that's kind of the motivation behind Herald. The idea is to really flip the pull-based model of collecting medical data on its head, and instead allowing clinicians to set up their own rules or protocols by which they can design the most useful ways of interacting with patient data. And it does this by interacting with a FHIR-based subscription data stream. So let me show you what I mean by Herald, and I was going to show you the demo version on our website, but I have the production running locally. I have the kind of latest version of it. So what you're looking at here, can you see my screen with the Herald in the upper left and my protocols?
Yes, we can.
Adam?
Yep.
Okay, great, thanks. So what you have here is a list of the protocols, and again, these are the rules that operate on the FHIR subscription data stream, and the events that we're looking at are lab type events. So you can see with my cursor, there's a phosphorus event, troponin, ABG, and I can set rules for any phosphorus that's resulted for this patient to be paged to me. Or, for example, if I want all troponins for any of my patients, page them if they're positive, indicating that a patient may be having a heart attack. So I can create these own my own rules for this by going to the create protocol and entering an arbitrary, say I want to check a potassium value. I can say that, create some condition around it, like I want to be informed if it's greater than 3.3 to be paged for that for all of the patients for whom I'm the attending, say. And I want to do that all the time. So there I've created my own rule, but in the process of getting feedback from our clinician users, we've identified that, well, I don't necessarily want to go through that process every time I want to create a rule. I can go and use the quick notification feature, so enter in an arbitrary MRN and say that I want the next basic metabolic panel that comes back, and there I've created a rule within seconds. But maybe I'm not clever enough to come up with the exactly most useful rules. So we have a feature by which I can essentially crowdsource or pull other rules that other clinicians have found useful. So, for example, as I'm scrolling down, I can be notified for any glucose value that's more than 350. So this is a pager rule, and maybe I don't like that 350 threshold. I want it to be 400 because I want lower sensitivity on my alerts, because that's what seems to work within my workflow. And then I'll just say that I want this list to be any of my patients, and there I have the rule. So this demonstration is built on lab data, but as you can imagine, it's a pretty, as a principle, generalizable, so that instead of just lab data, I can include, or clinical, kind of standard clinical data for that matter, I can include more kind of interesting concepts like patient-generated data, their weights or blood pressures that they're measuring at home, or perhaps a combination of variables like a risk score that pulls in data from all over the medical record, updated in real time through this event subscription, this event stream that the FHIR API, subscription API enables. On the output side, you can imagine some more sophisticated rules that allow me to, for example, instead of just alerting me about a glucose value that's more than 300, might suggest an order that maybe calcium gluconate or maybe IV insulin plus D50 that I can just instantly approve instead of having to go through the whole process of logging in to the EMR and going through that whole additional workflow step. Moreover, you can imagine routing this to people who might be better able to handle or process the information or have more effective action behind it. So that might mean you can imagine in principle this setting up rules that go directly to the patient to inform them about follow-up for their hemoglobin A1C that was abnormal. So we kind of envision this as a platform, and I'm starting with lab results as a first step. So with that, I will turn it over to Matt to talk a little bit about our progress so far. Matt, you may be muted.
He's unmuted on my end.
I can go ahead and take this part if Matt is having trouble getting in. So just to give a little bit of, can you all hear me?
Yes, we can.
Yeah.
Great. So just to give a little bit of background as to, Craig showed us the latest and greatest of this product, but this has really been something that Craig and I, who were both medical students or residents at the time, had been kicking around for a while. But this really came together at a hackathon at the Brigham and Women's Hospital back in November. And it was Craig and myself, and then Matt, who's having connection problems, and Andrew Hillis, who's our fourth co-founder. And we came together on this hackathon that was actually specifically focused on how can we make FHIR apps that can help improve the workflow within the hospital at Brigham and Women's. And we demonstrated a very early version of this concept and actually won a few prizes that got us sort of pushed us in momentum with this idea. By the spring, we had agreed terms with the Brigham to run a pilot. We won a few awards, including from Athena Health and from a Harvard-wide health challenge. But most exciting milestone is that we actually launched our pilot with our beta users at the Brigham just a couple weeks ago in August. So in terms of going over what this pilot is, Craig, if we could go to the next slide, thanks. The timeline of this, where we just launched it, it's a 9-month duration, and this is throughout the entire internal medicine department. Users will include medical residents as well as attending hospitalists for a total of over 300 users that will be using this product. Craig laid out a great vision as to where we can go from lab results today to this expanse of different inputs and output modalities in the future. In terms of what's within the scope of our pilot, what we plan to do is the lab data that Craig showed you now, we'll be shortly adding in radiology data, so be notified, say, if a new CT scan came back with a critical notification alert, or admission discharge transfer data to understand how patients are moving in and out or between different parts of the hospital. And the output modalities will include things like paging the physician, emails to the physician or to other people on the care team, as well as a secure SMS platform that will be rolled out of the Brigham shortly. And so we're really looking at this pilot in terms of 2 phases. The first phase is this beta phase where we initially rolled it out to these 10 users, as I just described, and we'll be continuing to roll it out in waves. And the thing we're excited about in this phase is we're going to be taking advantage of this rollout to assess the impact of Herald. So part of this is going to be around provider engagement, but where we do things like assess what's the churn rate of our users, or how often are they creating protocols. But we're also going to actually measure clinical variables, like is this affecting how providers are practicing? Are they ordering things more quickly when they use Herald? After our launch, after this beta period, we'll have a full-scale launch out to our whole user set for the second 6 months of the project, where we'll have ongoing data collection. I'd love to touch in our last minute or two on our team. So myself, I'm a recently graduated MD MBA student at Harvard Medical School, and actually have a background in computer science. So my role in the team is really to talk between a lot of the different pieces that we do, whether or not it interacts with the clinical side, the business side, or the technical side. Craig Monson, who spoke at the beginning, is actually a very similar background. He's even deeper on the clinical side. He is a fellow in clinical informatics now, recently completed his residency, and has really developed a lot of the code base that we showed off earlier. And Matt, who unfortunately was having tech problems, but has spent a long time at North Shore Long Island Health Center in New York, having a great sense for not just what we need to build for providers, but what we need to build for healthcare systems. And Andrew Hillis is our final team member, who is a PhD candidate in healthcare economics and can really help us grapple with the big data implications of this product that we're making. Finally, I'd just like to say thank you to the ONC and to the FHIR community. This has been a fantastic avenue for us to demonstrate our work, and we're very excited for phase 2. If you have any ideas about how we could continue to improve Herald, or if you are part of an early adopter health system, feel free to give us a contact. We have our email address here, or sign up for our newsletter on our website. Thanks so much for your time.
Okay, Brad, Craig, and Matt, thank you very much. Next, we are going to move on to Mark Tobias and Naveen Muthu from Phrase Health.
All right, hello, can you guys hear us?
We can.
We can hear you.
All right, let me,
And we can see your screen.
All right, great. So first of all, thank you for putting this together. I mean, that first presentation actually was really interesting because it's going to be pretty similar to what we're doing with a different focus. So we have a project called Phrase Health, and it's really public health decision support and integrating it to clinical workflows. Let's move on. All right, so Naveen and I'm Mark Tobias. I'm one of the clinical informatics fellows. I'm a second-year fellow now at the Children's Hospital of Philadelphia. I finished my residency in emergency medicine. I do my clinical practice at the University of Pennsylvania. I'm from California, went to school at Berkeley, and I was a computer science guy. I've built a lot of web-based applications and have been really interested approaching this fellowship kind of from a programming perspective, wanting to really get at the data in the EHR and then use it to create better outcomes and better experiences for patients and also for providers. And I'll let Naveen also introduce himself as well.
Yeah, so my name's Naveen Muthu. I'm also a second-year clinical informatics fellow at the Children's Hospital of Philadelphia along with Mark. I came here after I finished my residency in internal medicine and pediatrics at Georgetown University Hospital. So between Mark and I think we covered the majority of acute care providers that you might see when you walk into a hospital. My actual way I got into the field was actually that I have an interest in medical decision-making, did some research in that all through medical school, actually took a year out to do some more of that. And then, so I really come at this from more of sort of a cognitive informatics space, and we'll talk about sort of where we think that overlaps a little bit. But in terms of the problem, like Mark said, I think the first presentation was really interesting because I think we're working on a couple of different problems, but with kind of similar approaches. So the problem that we focus on is around sort of care processes in public health. The time that this was really in the news was when there was the missed, or I should say delayed diagnosis of a patient with Ebola in Texas. And following that, there was some publications in the informatics literature about really needing to improve the care processes and the communication of information and aggregation of information to be able to really make sure that these kind of cases don't fall through the cracks. And then there's another layer to this, which Mark will talk about.
So we really, I think Zika as well as Ebola exemplify this problem of really complex guidelines. And as clinicians, the way that many of you are familiar with how these alerts get disseminated are via avenues that aren't well suited for clinical decision support. And this often comes in the form of emails. We get email blasted about public health alerts all the time, and they're kind of these 3-page guidelines on what you need to do, and that can be really difficult to work with and to be reminded of when you're in the emergency department seeing somebody who may meet those risk factors. So we thought this was an area that was ripe for some better clinical decision support. So we thought about, is FHIR kind of one of the means that's going to make this easier, because historically it's been really difficult to get some of this data out of the EHR.
Yeah, so the idea obviously is not novel in the sense of having what we call an external clinical decision support system, but we think the technologies that FHIR enables are really, and specifically Smart on FHIR, which Mark will talk about, are really what offers some novelty here. So the idea would be that, whenever a patient is seen in for a visit, that the electronic health record has this ability to be able to push patient-specific data out to this external engine that then will be able to figure out, is the patient at risk based on looking at all the data that's being sent out. And then if the patient's at risk, then there can be some patient-specific recommendations that are defined. As you saw from the slide before, these can be actually there may be a lot of information that needs to come back about what lab, what kind of test, what sort of follow-up is needed. And so those pieces of those recommendations can be brought back into the electronic health record and displayed using something like SMART.
So this is probably not going to be new for anyone in this forum, but Smart on FHIR is kind of a framework in which it uses the FHIR standard of messaging to integrate applications into the electronic health record system and to allow the transmission of communication back and forth. So what this really allows an institution to do is query a complex guideline like Zika, be able to implement it regardless of which EHR they're on. As a lot of you know, the Argonaut project has really brought together a lot of institutional stakeholders and EHR stakeholders to sign on to this format. And it really allows the an embedded application to go into the EHR to access information as it's needed.
Yeah, so part of this is requires being able to obviously build the rules that provide decision support. So this is a screenshot of the prototype of what we've been using so far. So when we were thinking about specifically this population of people that are subject to emerging illnesses or evolving illnesses, so we really thought that there would be two pieces of information, or two layers of stratification for the rules that were important. So with Zika specifically, this exemplifies it perfectly, which is that one, you need to identify patients who are at risk for the disease and may communicate the disease but may not. Influenza is another great example of this, where if influenza is active but you're not an at-risk patient for severe complications, most of the time physicians don't really need to do anything in terms of testing or treatment. But then while that identifies a patient population that is something for the clinician to be aware of, maybe let's say they're in contact with somebody who's immunocompromised, or in the case of Zika, it's somebody, they have, it's a husband whose wife is pregnant, then they would obviously need to know, but it's not a high threshold thing. But then there's another population that's at risk for severe complications. So in Zika, this is the pregnant female. In influenza, it's the child that's 2 months old and can have fairly significant complications from the influenza illness. And so that's kind of how we've structured our prototype for how we're doing our rule building so far.
So similar to Harold, we have had a trajectory that started a little bit later. This really was kicked off by a Health 2.0 challenge that really pushed us along here. It was called the Closing the Data Divide Challenge. It was sponsored by the de Beaumont Foundation and the Practical Playbook, to organizations that really aim to improve the relationship between sharing data and getting public health more integrated into clinical care. So the mission that they had was to try and bridge the gap between those two, between providers and public health experts, So we proposed this idea, and we were selected as a winner of that. And that really kind of got us moving to continue to hone the prototype. We had it built in a development environment here at the Children's Hospital of Philadelphia within an Epic system. And from there, we've really been on tour trying to identify some potential pilot sites, figure out, similar to how Harold has done, figure out which metrics we're going to measure to show that it actually is producing outcomes that are beneficial and aren't, we're not just selling something that people can check a box off and say, we now have this tool. Obviously, outcomes are really important. And then obviously, as one of the phase 1 finalists of the Provider User Experience Challenge, that further kind of pushed us along and got on this path to really getting this moving. And we're in the process, as I'm sure all of you are aware, it's dealing with healthcare institutions is not something that is easy to do, especially when it comes to taking data outside of their system and putting it into the cloud. So there's been a lot of discussions and back and forth about how to best solve that problem, but it's definitely not an easy hill to climb.
Yeah, so we just wanted to thank, ONC for the Office of the National Coordinator for putting this together. This has definitely been sort of one more little catalyst for us to be able to get some traction to keep moving on our project. And so it's been really helpful, and we're excited to see this community sort of put together all these ideas. And, anybody that's interested in learning more about us can reach us through our website at phrasehealth.com. Thanks.
Okay, thank you very much. So next, we are going to turn to Kensaku Kawamoto from the University of Utah Duke Intermountain team. All right, we can see your screen. But we cannot yet hear you. Okay. I guess while we work on Kensaku's audio, we'll go ahead and move on.
You cannot hear me, right? Still cannot hear me?
Oh, now we can hear you.
Now you can hear me. Huh, interesting.
Yes.
Okay. Well, I don't know what changed, but you can hear me. Sorry about
that
technology. Okay. Thanks for the time. I'm going to just briefly talk about our project, which is a collaboration between our health system at Universitas Healthcare, Intermountain Healthcare, and Duke Health. We're working on enhancing a neonatal bilirubin smart on fire application that was initially developed at Intermountain. So it's my background. I'm the associate CMIO at University of Utah, overseeing clinical decision support and leading up some efforts in interoperable applications and services. I also help with a lot of government things. I do a lot of work on behalf of ONC, and I'm also on a National Academy of Medicine panel or group working on clinical decision support. Just as some disclosures, I am or have been in the past a consultant or sponsored research for a number of entities, including ONC. So this is a multi-institutional collaboration. At Universitas, it includes myself and others in the technical area. Carol Steppelman, who directs our Pediatrics, is also helping with this. At Intermountain, Scott Naris, who's the Chief Clinical System Architect, overseeing a lot of their interoperability and smart on fire efforts, is the key lead. At Duke Health, it's Ricky Bloomfield, who oversees a lot of the smart on fire type of efforts, as well as Robert Lemfesti, who is a neonatologist on the clinical faculty. So this involves also multiple EHR platforms. So it includes Epic at Utah and at Duke. Similar at Intermountain, we're also working to integrate with CareWeb, which is an open source EHR that was built at Regenstrief and is serving as the core open source EHR platform for the Healthcare Services Platform Consortium. And then anybody else who's interested and who has Smart on FHIR capabilities, hopefully will be able to integrate. So just some brief project background and motivation. So again, I think this group is probably well aware, but EHR vendors are increasingly starting to support Smart on FHIR to extend the EHR through interoperable apps in their production systems. So this is a bit of a change from earlier where a lot of vendors provided this kind of support, but they were in their vendor-specific approaches. And healthcare organizations across various EHR platforms could mutually benefit through the collaborative development of Smart on FHIR apps. So this is a little bit of a different take from the notion of let's create companies that sell solutions, which I think is great. I think there's also a real potential for healthcare organizations that are really trying to solve their needs to do so with like-minded organizations so that they can share the cost of implementation and sharing each other's works. So in this context, University of Intermountain and Duke are collaborating to extend an existing Bilirubin app with distance support as requested by our physicians. And we certainly welcome any collaborators, and we'll be making all of our content available free and open source for anybody who wants to use it. So this just shows what our baseline Bilirubin app was. It was developed by Intermountain. It's integrated, and this is just showing it integrated in our Epic system. We've blacked out anything that looks Epic-like, but for anybody who uses Epic, I think you can sort of tell what this is like. It's in your typical EHR workflow, and you can just click on the Bilirubin app, and it pulls in the relevant data, et cetera. So in this baseline app, it charted your Bilirubin levels as well as baseline expected levels, and what you see with these lines are essentially percentiles that were expected for those patients, so you could sort of figure out how they were doing. We particularly got requests from our pediatricians to add support for the American Academy of Pediatrics guidelines for hyperbilirubinemia management. And I guess there's a lot of physicians on the call, but for those who are not, bilirubin, if you get to elevated levels in the early hours of life, it can cause brain damage. So that's what you're trying to prevent. So there's guidelines here for phototherapy, and what you see here from these guidelines are the different thresholds for when you want to start phototherapy based on the patient's risk, based on their gestational age of birth and other risk factors, and also for exchange transfusion. So a little bit higher risk, but something you may want to do depending on the patient's bilirubin levels and your current hours since birth and your risk levels. So this shows our current state where we've worked on integrating phototherapy and transfusion guidance based on risk factors. So you can see here the blue line is the patient's bilirubin, the x-axis is the number of hours since birth, the y is the milligrams per deciliter for bilirubin. The gray lines are the lines you saw pretty much in the earlier version, which tells you percentiles that are expected from population-based estimates. The orange line is the patient-specific therapy guidance of when to consider phototherapy. The red line is when you should consider transfusion, and the purple indicates, based on our patient records, when phototherapy has been done for. So this is what we've implemented. We do encapsulate the distance support logic within something called OpenCDS, which we've led for a number of years, implemented in systems like the Veterans Health Administration. So this is an open source, standards-based way of authoring knowledge in a standard form. This includes, for example, these flow diagram-based knowledge authoring approaches. We do support a variety of standards in the distance support area. So we've implemented support for the Quality Improvement Core or QI Core FHIR profile, where you can find there. As you know, FHIR is very loose and doesn't, for example, for labs, as you can basically use any kind of institution-specific code you want for identifying what labs. Things like QI Core start locking it down a little bit to say, for example, use Link codes. It also includes things like birth time is not included in FHIR in the patient resource, and it includes that as a standard extension profile. We also use the HL7 Distance Support Service standard, which is a ONC recommended standard for integrating to distance support as a service. And we're working on supporting the FHIR clinical reasoning module, which really just recently became available in FHIR as a part of the main FHIR spec, which provides a standard way to represent knowledge. So there was a lot of discussion on this in support. There are standards that are being developed within FHIR to represent and to access these standards. In terms of status, we're well underway in our app enhancement. We're supporting institution-specific customization. For example, it became clear that some of our institutions have created their own bilirubin percentiles based on their own patient population and their population characteristics, and we're providing support so that you can customize basically the thresholds that you act on or that you believe are relevant for your patient population. And we'll be moving to implementation across our partners shortly. And I'll just note that I think this was true from a lot of what other folks have said too, but it matches nicely when we're trying to address these issues anyway, because we're doing it certainly, and we love the fact that ONC is doing this challenge, but these are things we would have been doing anyway in our institutions to really try to make life better for physicians and make patient care better. So I think it's great that we have opportunities now to more easily share what we're doing with each other. And that's all I have. I think it's, I'm out of my 10-minute time, so I'll just pass it back.
All right, thank you very much, Kinsaku. Last but not least, we have Craig Lamoli from WellSheet. And you'll need to go to the menu bar, click Share, and then My Screen.
Can you hear me okay?
Yep, we can hear you and see your screen.
Perfect, thank you. Oh, my name is Craig Lamoli. I am an MBA candidate at the Wharton School, currently on leave to pursue WellSheet full-time. So WellSheet is a point-of-care solution that uses sophisticated analytics to take a complex patient and put all of the important, relevant information about that patient on one sheet for the provider. And so we're really excited about the Provider Experience Challenge being selected as a Phase 1 winner. As you can see, our slogan is "Happy Clinicians Make Healthy Patients." So we're very deeply interested in improving the provider experience, and we really believe that that's one of the best ways to improve patient care. So just to give a little bit of background on the problem, doctors are now currently burdened with assembling a view of a complex patient across many different sources. From our provider interviews, we've heard that even just within the EHR, there's dozens of screens. It's not uncommon for them to have to go to dozens of screens to just within the EHR to collect information about patients, as well as going to various other providers. If they're fortunate enough to have a healthcare information exchange they have access to, they have to also access that source of information. And then increasingly, patient data aggregators like the ones in the consumer challenge are bringing data to physicians that they'll have to process as well. So you know, this aggregation process is something that we support, and also we really complement those other solutions that are doing that aggregation by being able to take that information and rather than it being spread across these multiple sources, we collect it onto, like I said, one sheet for the physician. And the way that we're able to do that is via a sophisticated machine learning algorithm. So the first source of data, as I mentioned, is that patient data to get a really clear sense for the patient profile and understand the, the set of conditions that they have and what defines them as, different from other patients that a particular provider might see. Then we also have processed tens of thousands of articles of clinical research from publicly available sources online, and we have processed those guidelines to build like a baseline foundation of our algorithm, which is able to really determine, based on that patient profile, the set of information that is most important to that particular provider user. And then finally, as providers continuously interact with the well-sheet interface, that continuously informs the algorithm, and it develops a better set of evidence over time on which to evaluate how important a particular piece of information is to a particular clinical context. And so that drives the layout of the interface, which I'll give you a preview of right now before diving into the demo. So this slide is really to illustrate the variety of sources that, the variety of settings in which WellSheet can be launched. So it's truly a cross-platform application in the way that we've built it, and it can be launched within the electronic health record itself, side by side with the orders and documentation that a provider needs to do. It can be launched in desktop setting as well as mobile, and this is all, as you know, supported by FHIR and Smart on FHIR, so these various launch contexts. And so we've built it out to support these various settings, and the providers that we've been working with have expressed different preferences about, what's the ideal implementation, but our first pilot is in a mobile setting at a hospital in Michigan. So we're conducting the integration for that particular pilot right now, and we'll be testing provider experience, efficiency, and efficacy metrics through that pilot when it kicks off. The timeline is early to mid-October. And so now I'll go ahead and show you a live demo of our web application here. And so the first thing that you'll notice is it's a very modular layout of information. This is really to represent the complexity of the algorithm that exists in the background. So we're able to really easily rearrange the elements based on the particular user. And so we have 4 columns of information: the timeline of important events for Melissa Johnson, her appointments and procedures, as well as her labs, medications, and risk factors such as family history, smoking history, that sort of thing. And the next thing that you'll notice front and center is these bright yellow stars. And what that is actually a representation of that algorithm. So it has pre-identified the set of information that the particular physician user should have to review for this particular patient. And so then the user can actually filter in specifically on that set of information. And they can very easily rearrange it based on their preferences. They can unstar particular pieces of information as well as star new pieces of information. And this, first of all, will hold in the future, right? So when they access this patient's records through WellSheet at a later point in time, the same layout will be stored. But then not only that, but similar patients that meet a similar profile will also have that same set of information by default displayed. So the physician doesn't have to redundantly assemble his view of that patient. Furthermore, as you look at the population of users, you can do some really interesting analysis to determine what is really the best set, the best workflow for a doctor when trying to treat particular types of patients. And so the next thing that they're able to do here is, if you are interested, for instance, in a particular problem, you can see the patient's problem list right here on the side. And so you can click in and it'll give a different ordering of the information to surface those key details for that particular problem. So if you're a primary care doc that wants to focus in on a particular issue, then you can have that view as well. The users can expand the tiles, as we call them, to get a quick view of some of the key details about different different data elements, as well as get a timeline of any quantitative elements over time. The search is also a good feature that, they can hone in on a particular tile. They can search even within the particular, the content within the tile itself. So they can really quickly get access, and that's another thing that we measure and incorporate into the algorithm itself. Finally, since the provider users have put the effort into doing some customization to their view of this patient, what we do is we apply some natural language processing to the tiles, and we're able to generate a report that they can then use the text from to kind of kickstart their notes. And so this is something that's still under development, but ideally, based on the set of data that's in the cover sheet for this particular patient, the report will be generated to contain the right set of information, so that any references to particular data elements that need to happen in the note itself can be pre-generated. The doctor doesn't have to spend any additional effort on. So the next steps for the application are building out that natural language processing to a better capacity to really support that note generation process, as well as the actual algorithm being able to continuously optimize. So right now it's really at that foundational point where it's based on those clinical guidelines, but we really need that user engagement to take it to the next level. So that's what we're excited to work with this health system in Michigan with, and then also we're doing some pre-integration piloting with Penn as well. Actually, I'll go quickly through the co-founders here, and three out of four of us have some connection to Penn. So we actually went through an accelerator program at Penn to kind of kick this off, and that's how the team was assembled partially. And so, I have the both kind of overall technical expertise as well as familiarity with the industry. I did work in kind of healthcare strategy consulting at IBM. I spent a lot of time on a care coordination project, specifically mental health with IBM. So I'm familiar with the needs of the executives at various health systems and the problems that those that the kind of enterprise-wide solution can generate for the actual end users and the providers. So a lot of the time, from what I saw, it ends up harming the provider experience rather than helping it. And we have, really strong, as you can see, it's a young team, energetic. So we have really good mentorship within the Penn Health System and elsewhere. But we have really strong design backgrounds, both with Mike and Justin, Justin is our clinical guy, and Mike is also pursuing a design degree at Warrior. And then Ryan really has the implementation expertise and has worked with hospitals to implement the EHR integrations and launching products to improve efficiencies. Both I worked with him at IBM and also at GE Healthcare. So we're really interested in expanding to new health systems as well, and to really leverage the power of FHIR and Smart on FHIR to deliver, a better user experience for providers.
All right, thank you, Craig. The last thing we have on our agenda today is to just talk a little bit about the upcoming Phase 2. So Phase 2 is currently open until Monday, November 7th. We will be having a final live Q&A webinar a few weeks before that, so stay tuned for the exact date on that. And then we intend to announce winners before the holidays in mid-December. Final submissions will be reviewed on these criteria: the number, source, and types of data brought into FHIR or brought into the app using FHIR, the functionality and quality of that aggregation, the privacy and security of the data, the user experience and visual appeal, and the impact potential in the clinical setting. The final awards for Phase 2, first place will receive a $50,000 award. Second place will receive $25,000. And there is also an Ultimate Connector Prize of $25,000, which will go to the app that connects the greatest number of unique pairs of EHR vendor systems and providers using FHIR. And anyone, including the first or second place winners, can win that final prize. And again, Phase 2 is open to not just the Phase 1 winners, not just Phase 1 participants, but also anyone who did not participate in Phase 1. Finally, you can find more information about the Provider User Experience Challenge at that second URL there, or a little bit easier, just go to challenge.gov and search for FHIR or provider. Additionally, you can email the host of this webinar at the email address at the bottom, jshapiro@capconcorp.com, or email me directly at adam.wong@hhs.gov. So I would just like to thank and congratulate our Phase 1 winners. I know ONC is really excited about what has gone on thus far and can't wait to see what kind of submissions come in for Phase 2. So that wraps up today. Thank you very much and have a good afternoon.